Dobar dan, and thank you for welcoming here to the beautiful Novi Sad. So I'm very happy to be here, and I will be presenting a bit about working with Net Cdf files. So this will be a practical session, so a bit different from the morning sessions. So it will be very practical. So maybe some of you are already a bit familiar with Net Cdf files, and things will be a repetition or things you already know. And for some of you, this will be new. However, I'm sure you will manage just fine anyway. So I heard you are a mixed crowd with very mixed backgrounds. So just to make you feel more comfortable with that, I am a doctor. My doctorate is not in climate science, it's in cosmology. And I came to this field 4 years ago. And I'd never heard about these files before then. And so it's possible to learn how to do this, whatever your background is. So now you'll see my slide, right?
No, we can't see the slides.
So there's yeah, let's just do this, I think.
Now we can see them.
Yes. There we go. Okay. Yeah, this is just my header slide. So what are Net Cdf files? That's the starting point. So Net Cdf files are sort of the answer to a question that you may or may not have already. So we'll go through that. So that's the first point of the agenda. Then we'll go through inspecting them and looking at them with a program called ncdump. Then we will be viewing them with something called ncview. Then we will go through where we will get all these Net Cdf files from. So previously from Carly and Jana, you've heard about climate models. So we'll go and see how we can get some climate model data from the sort of biggest climate model repositories, which is called EXtremeClimTwin. Then we will look at some data from reanalysis. So you also learned about reanalysis data sets. So we'll look where we can find some reanalysis data, and in particular, we'll look at the Copernicus data store, because in there they have a slightly particular way of letting you obtain the data, which I'll show. And then we'll do some manipulation of Net Cdf data with Cdo and with NCO. And finally, we will go just really quickly through how you can start working with Net Cdf files using Python. So that will, I guess, be familiar to you to a certain extent from what you learned in Tom's session. So what are Net Cdf files? So from Carly's talk, you'll recognize this picture of the globe with different grid points layered on top of the globe and also going down. So from a climate model, the output is a really large data set with different values for a lot of variables like temperature, humidity, wind speed, and so on, both in geographical grid locations, but also in different layers, going up into the atmosphere, going down into the ocean. For some things, it's going down into the earth, so that you could look at humidity in different layers in the soil, and so on. So there are a lot of data for a lot of grid points. So they, with horizontal, latitude and longitude, and vertical height and pressure. And in addition, this is the snapshot from one point in time. And a climate model, of course, runs over to simulate how the climate will change over time for years. So, and time points can be written out as often as every hour or every 3 hours, every 6 hours. So, of course, you get a really large series of data. So how can you save and use these data in a sensible way? So one thing is that climate models are being run all over the globe. So there are many different climate models being run in the US, in various places in Europe, in Asia, in Australia and so on. So there are researchers all over the world running different climate models. And in order to get the best science from this, we need to be able to compare the data from the different climate models from different places. So people need to be able to open them and do science on them, whether they're located in Africa or in the same institute that ran the model will say in Canada. So the format has to be international and be usable for several different disciplines. So it could be geosciences to climate science to more hydrology, and also for impacts, they need to be usable for social scientists and so on. So there has to be a standard that everyone conforms to, so everyone can open the files and everyone can use the files and compare and do science with the data. Like I said, it has to be multidimensional because we have latitudes, we have longitudes, we have vertical layers, we have time variables, we also have time points, and we also have many different variables. We have humidity, we have temperature, we have wind speed, and so on and so on and so on. And the data need to be gridded because that's just how the climate model data is. In terms of data for weather stations can also be used in the same format, and we can make them gridded in a way where our grid is not necessarily the sort of X by Y equal boxes over the globe, but the grid can be the various stations that we have and various sort of measurements at each of the stations. So it needs to be flexible also in order to accommodate different data sets, both these sort of obviously equally gridded data from a global climate model to something that might have very few grid points or be observational data, data running over short time series, long time series, huge data sets and smaller data sets. And you need to also be flexible. So say I run a time series for a while, and then I want to add more data after a new time interval. So it needs to be flexible in order to be able to add more data on and accommodate many different types of data sets. And it needs to accommodate something that's large. So accommodating small quantities of data is not really a problem. So Net Cdf files can, of course, also accommodate really small data sets, but the real challenge is in really large data sets with lots and lots of data. But the answer to all these questions is Net Cdf data, which was come up with in the US in the 80s and has been developed from there to be a dataset format that conforms to all these things. So, of course, it's a standard, so that means that it can be international and multidisciplinary. But the Net Cdf file also has metadata included in each of the files. So it, of course, depends on what you actually put into your Net Cdf file, but generally the file would have information. What are the variables? What are the units? but also things like who generated the data or made the observations, who can you contact in order to check if you find something that might be erroneous in the data. There's data on what sort of manipulations has been done on them, licensing, and lots of other things that make them much more useful for many more people. They are gridded, so they are naturally gridded, so all the data are organized according to different dimensions. So you could think of, let's say that you put a data set into an Excel file or similar, you could add the X and the Y axis and you categorize the data from there. But in a Net Cdf file, you can have as many dimensions like that as you want, without it being extra sheets and so on. So all the data are sort of organized according to these dimensions. It's binary, so that means that it's not really human readable normally. It's machine readable only. And by being binary, the file can be packed much more efficiently. So this is a really good way to deal with the large file issue. So having this gridded format and then having it be binary, we can accommodate much larger data sets. And the standards in which this binary format is made makes it possible for us to use different sorts of software to look at and get a hold of and work again with the data, which is normally stored as binary. So there are a few, since this has been developed for a long time, there are a few different versions of Net Cdf, but all the versions are more or less compatible. So a more upgraded version might be better packed, so you might save some space by going from one version to the other, but you should be able to open the files, see the files, even if they are in an old Net Cdf version format. And the file extension is usually .nc, could be .nc4 for netcdf4, or something like that as well. So that's how you normally recognize that it's a Net Cdf file. If you're downloading, you see the file and it has this type of extension, you can be quite sure that if it's data from climate, meteorological, geosciences, then, and it has this extension, it's a Net Cdf file. Okay, so on to inspecting Net Cdf files. So binary, as I said, is really hard to read and understand for humans. So we need something to interpret it and look at it for us. So Net Cdf converts the Net Cdf file to an ASCII format, which is readable for us. And then by doing this, we can understand how the data are organized and what they are like in a much easier way. And we can add different, so normally we say Net Cdf and we say the name of the file and we get a lot of ASCII output. So normally we could either send this ASCII output to a different file, or we can use an in-terminal editor like less to see the data in a sort of, not the whole data stream in one go, but slowly so that we can see it from the top. And if we, and Net Cdf also has different parameters that we can send in order to do slightly different things. So if we do ncdump-h, we just get the header, which is just the metadata. And ncdump-k will just give us the file version. So if it's Net Cdf4, Net Cdf3, or so on, that might be useful sometimes. Net Cdf-v and then the name of the variable just shows you the data for the variable name. For more info, you can find this address. No need to take down notes. The presentation is available in your in the folder, it should be available. So let's see. Okay. Then we are going to see some examples of Net Cdf files. So I am just going to go ahead and share my screen. So you'll see my screen now, right? Yeah. Which one? Sorry, just a minute. Yeah. So here I have a folder with some files in it. So I will, and I've pre-downloaded a file here for you. That's
Right. Could you please make this window a little bigger so that we can read? Increase the size of the window. Yes, thank you.
Yeah.
The text also.
And the text as well.
Yeah.
Thank you.
Sorry. Like this.
Yeah, this is better. Yes, thank you.
No worries. So then let's look at this file. It's CMIP 6 climate model run with the model CANISM5 for future projections with the SSP 585 projections. So let's look at that one. We can see in the top here, it says it's a Net Cdf file and the name of the file. Then it says which dimensions we have. So what type of a grid we have. So first there's a time dimension, and time dimension is normally treated a little bit differently from other dimensions in Net Cdf. And that's why it says unlimited here. So it's unlimited in the sense that we can add on more data at the end if we want, at some point more easily than for the other dimensions, whereas the other dimensions are constrained to be a set length from the start. And here it says it has 31,390 values currently. So that's all of the days from 2015 to 2100, as this is daily data. And then there are latitudes. There are 64 latitudes and 128 longitudes values in the grid for this model. So it's quite a coarse model. So that's our dimensions. And then we have the variables. And normally for each of the dimensions, there's also a variable named the same, which says what the value of that dimension is at each of the dimension points. So the days will have how many days since 1850, 1st of January. And it says what type of a calendar it has. So it has a 365-day calendar, which means there are no leap days in this calendar. So it's not a completely physical calendar. That's quite usual for climate models to have this type of calendar. Then it has latitudes, and longitudes also have units of degrees and axis names. And finally, there's a variable that's actually in here, which is PR, which is precipitation flux. So it has both units, it has different types of names. It tells you that it includes both liquid and solid phases, which means it's both rain and snow. And then it says a little bit more about what's been done to it after the climate model ran. And then there are some global attributes. So in the global attributes, we, for instance, get some contact information for the people in Canada who ran this climate model. It tells you what date they did this run. It gives you some a URL where you can find more information. It gives you more information on the grid, on who made it, what institution made it. There are references that you can put in, and so on. So there's a lot of information. And then after that, we get the actual data. So now we've done with the metadata, and the data starts where it says data : So first, it has a time variable. And here it says all the time values that are in. So that's just the days, which are days since the 1st of January of 1850. Those are those numbers. And then there are some bounds between the values. So that just says what's the values on the boundaries of each time grid box. So it's usual, but not all Net Cdf files have them, but it's useful to have boundary layer definitions of your grid boxes. And this file has that, and so on. And we can go on for a very long time here, but then after it has the time variable, it will then have the longitude, the latitudes, and then the data for the precipitation. So if we do the -v ER, we get the same metadata, but then when we come to the data part, it doesn't list the time first. It just starts listing the precipitation data. Which is then organized according to the 3 different dimensions. Okay. So let's go back to the presentation. So maybe I can just do that here. So now you see the presentation again. Yeah, so here's just a screen dump of what I showed you on the screen. Then, so Net Cdf is geographical data normally. So seeing it visually and showing it on a map is also a really good way of getting some overview of what your data look like. So for that, you can use Panoply, which I think maybe some of you know, but I like to use NCView, which is a viewer for Net Cdf files. And it plots the data on geographical grid. So what we can do then is I have to load the program. And then we can look at the file using NCView. By the way, feel free to ask questions or stop me if something is unclear. So here we can we see the different variables in the file and we can plot them. So if I were to plot the latitude or longitude bounds, I would just get a sort of graphical view of that. So, but if I click the precipitation, I get a sort of global map with the precipitation shown. there normally is a scale shown for the color scale, which isn't here now for some reason. So, and we can see which date this is for. So this is for the first data point for the 2nd of January 2015. And what I can do is I can go into the next time point and the next time point and the next time point to see how the data changes, or I can even make it sort of go continuously through the data points like that. I can also go back and I can change a lot of options here. So if I don't like these really big coastlines, I can change to smaller coastlines. I can change what sort of color map I want. Now it's a rainbow color map. So maybe I prefer a different color map, and I will move that one to the top. And I can say, okay. And then you see that the color has changed. Now I got the color range scale here visible. I think in principle, at least the coastline lines should have changed a little bit. I can turn them off as well if I want. So there are, of course, a lot of other things that we could do here, but those are the sort of main things. It's a really good tool to just get an overview, especially if you've been manipulating your Net Cdf files. Say you've made some transformation, maybe you wanted it to go, you had some temperature data you wanted to transform from Kelvin to Celsius, or you wanted to do some type of regridding. It's really good to just look at the data in the map and see if what you get is sort of borderline sensible. At least that's a good first test. Okay, so let's go back to the presentation. Okay, so let's get some climate data. So this is ESGF, and I think Carly also showed you this site slightly the other day for looking at climate data, and it's also kind of an answer to some of the same questions that we had in terms of getting Net Cdf files. It's climate model data being produced and used by people all over the world. So how can we pull all this data and make the most of research out of that? So we have a huge swath of different climate models and different, and they produce a really, really unfathomable amount of data. So the way it is organized in order to have this data be shared is and comparable is that we designed these model intercomparison projects to have the models do sort of the same experiments and produce sort of the same data output. And that's accessible for CMIP 6 and CMIP 5 and Codex, which are different sort of bags of experiments like this from ESGF. And the way ESGF works is that the data are actually hosted somewhat locally. So say the Canadian data are hosted in Canada and the Australian data are hosted on a server in Australia. And the Norwegian model is partially, or the Nordic model is partially hosted on the Norwegian infrastructure and so on. And however, there's a sort of large hub then that connects all of these nodes and gives you an interface to find the correct address in order to download the data files that are located all over the globe on different servers. And this interface is, again, found on different nodes. So there are different nodes that you can log into and download the data, or get the interface to find the data and download it from. So there are many nodes to download the data from, and then also there are many nodes that hold the data. And these are a couple of addresses. There's one, the LLNL is US-based node. The DKRZ is a German node, and there are lots and lots of nodes. And what's really useful, so it feels like when you go and use this the first time, you think that you might think that all the data are in the same place and you can always find them. But if a node is down, that means the data might not be accessible. So there are two things that can happen when a node goes down. One is that the data that are actually on that node or connected to the server that is down is not accessible. But the other one is maybe you're connecting to a node which isn't fully up at the moment. And in that case, you might not see that data are available for other nodes. So it's useful to have at least a handful, 2, 3 maybe, different login nodes that you go to. So if you don't find the data in one node, you can check on another one, because sometimes for at least short spans of time, the data might be available from one node, but not from the other. And it's always good to check the node status if there is some data that you think you should be able to obtain, which you can't get hold of. Yeah. And there's also a really useful page, which I linked to here, which tells you about the status of data. So sometimes when a data model is run, something goes wrong. So either some files can be corrupted, some files can have an error in them, some files, somehow the run went wrong a little bit and there's a weird phenomenon going on and they have to rerun that experiment. And on this page, they update when they find these types of errors in the files, so that you can find out if the data that you have is erroneous. And that also means that the data that you find on ESGF is updated every so often. So it's a good practice to keep track of the version number for the file that you have and state in your research which version numbers you use, or at least make it possible to find out which version numbers you used. In case you produced a paper using a data set with a certain version, and then maybe a couple months after you finish your paper, an error was found in this data set, and maybe some of the research that you did was either contingent on that error, or the run had to be run anew, and some statistical part of the variability of the model made the results a little bit different, and it's hard to reproduce what you made. So that's just good form. So let's see. So let's go and look at some look into how we can use ESGF. So here. Do you want me to increase the size for this as well?
Yes, please.
Yeah.
This.
Like this?
Yes.
Yeah. So this is the US node. So one thing to know, first off, is this is what the site looks like when you're logged in. So I really recommend, if you plan to use some climate data, or maybe even if you don't plan to use some climate data, it's really useful to have an ESGF user account, because there's much more functionality in ESGF that you get access to if you have an account. And also, there are differences in data. So CMIP6 and CMIP5 data are open to everyone. So even if you don't have a user account, you can still get the data. But some other data sets, for instance, Codex, which we can't really see from here because this LNNL node doesn't host Codex data. That is only available you have to apply for and get particular access. And if you have a user account, you can apply for this access, and they're not extremely stringent. So if you have a good reason and a research project that you want to do, you will normally get access to the data that you want. Okay, so let's go and look at some CMIP6 data. So we go to CMIP6 data search, and we see on the side here, there are a lot of different options we can do in order to narrow down our search to find the data that we want. So let's say we are looking for some data again from this CanESM model. So here is the source ID tells you the name of the model. So there are really a lot of models, as you can see. So let's just check the CanESM5 model. And when we and you see the number here, this is a number of files that the CanESM5 model has delivered. So it's really a lot of files. And when we click search now, we start to get a list of these 761,030 files. Of course, we probably like to narrow down a little bit more. So what I'm going to do is I'm going to look for historical experiments. So here's all the experiments. And when I've narrowed it down to CanESM5, you will only see the experiments that CanESM5 has run. So before I check the CanESM files box here, there might be even more experiments, but that CanESM for some reason didn't choose to run. So I choose this historical experiment, and that's one of the mandatory experiments. So nearly all models have delivered data for that. And let's say I want the daily precipitation data for that. So here I can choose the time frequency of the data. There's 3-hourly data, 6-hourly data, there's daily data, there's fixed data such as orography and landmasks. There is monthly data and there is yearly data. And then I would like to find the variables. So there are particular variable lists that you can find where you can find the CMIP6 names for different variables. So they are good to look at as a starting point if you're unsure what the variable, because some of these are a bit difficult and obscure to understand just from seeing them. But if you know what you're looking for, then you can find the corresponding OK name, and PR is the precipitation variable. And then we search for that. And then we'll see that still there are 50 different results here. And the reason why there are still 50 different results here is that, I don't know if you remember, but, or maybe he didn't mention in this early stage researcher grant, but talk, but he wanted there to be also different runs of the same model and not just high resolution in order to see the variability in statistics. And this is exactly what CanESM5 has done. So they have run their model 50 different times for the same experiment, so that you can do research into what's the internal variability in the model. So that's 50 different realizations. So the climate is sort of the same, but of course the weather will always be different. And this could be a really good resource, for instance, in looking at extreme values. So here we have 50 different, the 50 different variable names. So let's say I want to see so let's say I want this file. If I don't have, if I haven't logged in and I don't have a logging name, what I can do then is list this file, and I can look here and see there's an HTTP download, and I can just download that particular file directly. So I can just click that, and the file will be downloaded in a while. It sometimes takes some time. However, oftentimes you want more than one file. For instance, you might want many of the ensemble members for Canis M5, or you may want several different variables from the same experiment. Maybe you want to look at several experiments and the same variable and so on. And then you can make your search so that you get all of the things that you want, and you can add many different of them at the same time to what's called your data chart. So now let's just add all of these ensemble members on the first page. So there's 10 search results on each page, and you go and see the next one and the next one. So for this one, there will be 5 different pages with 10 results. But let's just add these 10 first ones. So I added them to my data chart, and now they're listed as unavailable. So this might be because the node where the data are is down at the minute. So if we look at this list, let's update that one. So yeah, so you can see here the data node where the data is at is called crd-esgf-drc-ec.gc.ca, and we can see that this node came down just now. So that's why the data are probably unavailable now. So if we wanted to download them, we would have to wait for the node to get back up. Anyways, I've now added them to my data chart in the hopes that the node will be back at some point, and then I can go in my data chart and see them. So here, all the data that I have added to my data chart are here. And with your data chart, you have several different options. You can, for instance, toggle one or more data sets. You can even toggle all of them. And you can get, instead of clicking every file and doing an HTTP download, you can get a script that will download all of the files that you've toggled for you. You can also, for CMIP6, there's only one variable in each file. Whereas for CMIP5, all of these sets might include a lot of files with different variables. So when you get a search hit and you put it in your data cart, maybe there's precipitation, but in the same data set, there might be temperature, there might be humidity, there might be wind speed, there might be all sorts of other things that maybe you are not interested in. And then you can enter that text into the search field here. So if you want PR, you could do PR like this. You can apply that. Then all of the files that are not precipitation will not be part of the lists of files anymore. And also when you click show wget script, the script that you get will only give you the precipitation files. So now I've made a script, and I can click that one, and I can get and download that script. So now I've downloaded a script that can, again, download all this data. So one important thing to keep in mind about this script is ESDF has a particular setup that if you make a download script for more than 1,000 files at a time, the download script will only work for the 1,001st of these files. So I'll show you in the slide after some extra links on where you can go and find out more about how to tweak these things. So in practice, if you run into this problem with 1,000 files or a couple of other problems that you may run into, there is options to solve those problems. Okay, so now I have this wget script, and the wget script is here. Well, actually, it's not exactly the same one because I cheated and I downloaded it before as well. But in principle, it's the same one. So how I then go about downloading the file is I run the script with the program called bash because it's a bash script. And I have to have a -h behind because that lets me give my username and password so that I can obtain the files. So now it says I have a script for 10 files. I have to put my username, which is a very long URL, which is what it normally is for all ESGF IDs. And there we go, it's downloading the files. And this script is kind of neat in that it both downloads the files and it also checks if the file has downloaded correctly before moving on. So what you often do if you have one of these scripts with really a lot of files, you start it, you let it do the downloading in the background somewhere, and maybe oftentimes not all of the downloads went through, so you run the script over again, and if the files are already there, they will just be skipped when you do the download. Okay, so let's return to the presentation. Yes. Yeah. So this is what ESGF looked like, just what we saw previously. Yeah. Still no questions? Everything's crystal clear?
Well, I think that we're okay at the moment. We're just watching what you are doing and wondering how can we replicate that in the future.
Okay. So let's move on to reanalysis data. So here I've just first added some links. So for the reanalysis data, there's not this sort of one stop shop the way it is for climate data. Of course, there are other climate data as well. So there could be smaller intercomparisons projects. There could be just particular runs that people have done in different contexts, and they can be obtainable in various ways. But I'm not going into that. But in terms of reanalysis, the picture is a bit different. So reanalysis are being run by many different institutions, and usually the reanalysis data is obtainable from that particular institution. And each institution has their own kind of way of letting you get a hold of the data. Most of them include, just as for ESGF, that you register and get an account. But then, and that you can browse through in one way or the other to find the data that you want. And then very many of them would either give you sort of a link that you can click, which you can also use Tom's setup for web scraping and downloading the data to get a hold of. Or they might give you a list of links or an FTP channel where you can get them during a limited time frame and so on. And most of these things are described in a fairly okay fashion where you try and get them. So for Merit 2, for instance, you make your selection in a similar way to what we did for ESGF. And then in the end, you get a list of files of URLs. And then you can just loop through and get all the files from the listed URLs. So here are some links to, I think it's most of the different reanalysis data that Carly mentioned are available through these different links. So I will show a particular example of obtaining reanalysis data from the Copernicus data store, because it employs a slightly different way of obtaining data, where you get a Python script that you can run and where you can actually manipulate directly on the page, or you can download and manipulate to your system. And the EXtremeClimTwin database works in a very similar way. So it's useful for both of those. So I've listed both the link to the where you can find the data sets on Copernicus, and also an API on how to use the data store. So let's go looking at that page. So let's see. Here we are. Here's the errata file for ESGF, and here is the Copernicus data store. Let's go back. That's error 5 particularly. Okay, so let's go here. So let's start by looking a little bit on this how-to page. So here we have some info on how to install the Cdsr API, because you need a little bit of software in order to use this and download the files to your system. So what you have to do again is start by having an account and log in. And then you choose your system here and install the Cdsr API. And then afterwards, you have to add a key to your system. Details on how to do that is there. So here we see the data sets that we can look at for ESGF and for CDS. And CDS doesn't only have reanalysis data. It has some other types of data as well. For instance, Jana mentioned earlier that the ETCCDI indices and some other heat indicators. And in a couple of months, we will be adding a data set to CDS, which, okay, there was something really weird with the view here. We will be adding a data set of climate indices. So we have calculated, Carly and Jana and I and our collaborators at Cicero, we have calculated these ETCCDI indices for all of the CMIP6 models that have the sufficient data to calculate them for both historical and the foremost usual SSP scenarios. So that we will use CDS to share that from a month from now. So that's an option, or will be an option. So let's choose the reanalysis, and we only get the reanalysis data here. Let's go to the, let's say we want error 5 PR data that's daily. So let's say we want to find something similar to the PR data that we found for CAN-USM5 to compare that to. So error 5, it doesn't have daily data. It only has either hourly or monthly data. So in order to get daily data, we have to take hourly data and transform it into daily data. And we want hourly data on the surface, that's single level, that's mostly surface data. The single level, otherwise there's on pressure levels. So then you get data on the different layers of the atmosphere. So let's go into this one. And here there's an overview about what the dataset entails and lots of really great metadata. Let's just go to the download tab. So we want a reanalysis, and what we want is the total precipitation. So this is not precipitation flux, but total precipitation that error 5 reports. So it's important to keep track of. The variables might be slightly different, but in principle, they're measuring the same thing. So let's say we want the data for 2020. And we want the whole year. And we want all of the days. And we want all of the times. And let's say what we want to look at is primarily the Southeast European region. So then we can choose, not if we choose the whole available region, then we would choose the whole globe for error 5, because it's a global reanalysis set. But instead we can choose a subset that we want. So maybe you disagree on how I've defined Southeast Europe, but I'm going to go ahead and go from 10 degrees to 30 degrees easterly, and then from 35 to 50 north. That might be a slightly generous Southeast Europe, I don't know. And then we want it to be a Net Cdf file. Grid is another climate format that you might get to see somewhere. It's possible to convert between grid and Net Cdf formats, but usually Net Cdf is more useful. So then what I'm going to do is show the API request. And what comes up then is a little bit of code. That is the code that's required to download this particular data set. So what I do then is I copy all of this code. And I go back here. I abort this because I'm not going to wait for that one to go on forever. Then I open a file where I can add this. So let's see, the file came in here. And then I just add all of that code. And then I can run this file and I will download the data. So I can also change the code. So let's see, I might want to make this file so making a more sensible file name, something like this. And what I could also do is, what I normally do is I could let this part just be a part of my code. And then I can, for instance, loop over a lot of years so that I get the data for many years rather than just 2020. So in principle, you could get all the years from the interface as well. But the interface doesn't let you get the code or get the data directly if you're downloading too much data at a time. So sometimes you need to share it so that it's 1 year at a time that you download. Otherwise, the request won't go through. So that's one thing you can do. For instance, this is hourly data. So often if I want daily data, I make a little bit of code down here as well, which transforms the data to daily data directly, then deletes the hourly file so I don't have to sit on these huge files. And then I move on and download the next year and so on and so forth. So that's different things that you can do when you have this code piece. It's really actually very useful. So what I can do now is run this code. And oftentimes, so for instance, just after, we will go through also some tools called Cdo and NCO, and oftentimes I use these tools as part of this script to, for instance, make the hourly data into daily data. Some data is not actually available in the form that you wanted, so you might want to change units or something like that. For instance, humidity specific humidity is not available directly, but EXtremeClimTwin gives you a formula for how you can use the other variables to obtain that. So you can put that conversion directly into your code, and then you get those files directly as well. So that's very useful. So let's just run this code. So what it does then is it uses this API and then it sends the request to the queue. So now it's this request is queued. Okay. So let's return to the presentation. Yeah, and from the CDS, you can also get the European Regional Reanalysis URERA, and also there's a set called WDFE5, which is a bias corrected version of error 5. There are many different versions of error 5 as well that you can get. Okay, so moving on to manipulating files with Cdo. So since Net Cdf files are this particular binary, slightly strange format, it's actually a bit difficult to manipulate and work with the data. So it's really, really useful to have specific software that knows what the format is like and can do all the backstage fixing the binary stuff. And make you able to do sort of obvious type of transformations in single goes. So the general syntax of Cdo is you say Cdo, you say some operator. So Cdo has tons of different operators. Then you say the file that you start with, and then the file that you get out. So for instance, a really simple thing to do would be to add a constant to all the variables at all the grid points. And this would be Cdo, add C, that's add a constant. Then you say the value of the constant. So here it's adding 1, the in file, NC, and then you get an in file plus 1 at. And that's really simple things that you can do, but you can also do really complex things like regridding your data. So what you can do then is do Cdo and then get a grid description from a file with the grid that you want, and send it to a new grid description file. So this is the grid description file then. And then afterwards, you do remapping. So in this case, it's a bilinear remapping, but there's regridding of various kinds that you can choose. Conservative remapping, for instance, and so on and so forth. So you can choose which one is the best for your purpose. And then you send in the destination grid that you want. You send in the file that had the wrong grid, and then you get a file on the right grid out. It has statistics on single files or ensemble statistics. It has time concatenation. It has regridding, subsetting, arithmetic operations. And here's a URL to the user guide for that. And it's really, really a lot of things you can do. So it's just to go and search through that file. So let's look at that in practice a bit. Let's first open the documentation. So here we go. There we go. So, like I said, the error 5 data are on an hourly resolution, whereas we would want to compare it to data on a daily resolution. So let's look for, and with this user guide, you can look in the contents and you can see the different chapters, what types of operators they are on. But normally what I do to find things is there are so many things that you can do is I first try and think of what is the problem that I'm trying to solve. And is this a problem that I think other people have encountered before? And very often I think at least some subset of the type of problem has been solved by other people before. So in order to get that, I Google for solutions to the type of problem or the type of problem that I'm looking for with Cdo and Net Cdf in addition to the problem. And then I often get a couple different hits which show what other people have done, including something on an operator. And then I go search for that operator in the user guide. So in this case, the thing that I'm looking for is called day sum. So it's a daily sum, and it's in this huge list of operators that give you various statistical values. And yeah, there's no particular usage here, so that means that the usage is relatively simple and straightforward. So let's try that out. So this operation is still queued, but I've cheated, so I downloaded the file before so that we don't have to wait for that. So I have that same file, but with a slightly different name already. So I type Cdo day sum, and then the file that I want is called error 5 2020. And then I call the new one, which is on daily resolution, error 5, 2020.nc. And what I get is an error message. But don't fret. Error messages are here to help you out. So if you look at the error message, you see that the values have need more space than 32-bit digits can give you. So you need to increase the output precision, and it even tells you how to do that. So we add on the B, F64 as suggested, and run the command again. And then we have processed the data, and now we have a daily file. And then we have, so we wanted to compare these two files. But of course, our error 5 file is just for Southeast Europe, whereas the Cdsr data, they are global. So let's try and see if we can't do something about that. So can we use Cdo also to pick a geographical box outline? And it turns out that we can. And the operator that we are looking for is something called cell-lon-lat-box. And here we see the usage of that. So it has, maybe I should zoom in for this. You see properly now? Can go to 200. Okay, so it says Cdo, cell-lon-lat-box, and then it says the degrees that we want. And let's see, here's also the one. So it's the first longitude, the second longitude, the first latitude, the second latitude, and then the in file and the out file. So let's try and do that for our Cdsr file. So I've also remade that command so that we don't have to do typing all day. So here's the command. It's cell-lon-box, and you recognize the same latitudes and longitudes that I chose for Southeast Europe. And I take the precipitation file that I have pre-downloaded that we looked at earlier, and I make one that's called SE, Southeast Europe. Okay, there's a mistake. Yeah, there's a mistake in that command. So this one should be part of the operator like this. And then we have a file that's being translated. Okay, so let's move on in our presentation. So a similar tool, which has a lot of overlap but can also do other things, is NCO. And NCO is similar to Cdo, but also different in that it hasn't got everything in one big NCO and then operator. Rather, it has a couple different types of operators that have different uses. So there's NCAP2, which is an arithmetic processor, which is the one you can add, you can subtract, you can do formulas with it. There is NCATed, which is an operator which can change attributes of a file. So say you want to change what your unit is called, or something like that. That's good for that. There's NCES, which does ensemble statistics. There's NCCat and NCRCat, which are concatenators. So you can add times to each other, you can add geographical to each other, and so on to concatenate the file. There's NCFlint, which is an interpolation tool. So say you have data for every 5 years and you want to just interpolate and make up data for the intervening years, you can use this one for that. There's NCKS, which is a kitchen sink, which is a tool which does a lot of different things. So I won't go into details, but if you Google NCO and you have a problem, you might often find that the solution is using something to do with NCKS. There's NCPDQ, which is a packaging tool, which can actually help you to make the binary file even more compact. And it can take a file that's been packed in a particular way more easily readable. So one way of packing, for instance, is to take all the numbers and find the mean and subtract the mean and make all the and also have and also divide by some sort of size, so that all the numbers become numbers in a very small range. And then you can use this tool to unpack files that have been created this way, or make files that are smaller because they are organized this way. And CRA is a statistics package. NC remap does remapping, so you can do remapping with NCO as well. NC rename can rename variables and attributes. So if a variable is called one thing in one file and another thing in another file, you can use this to rename the variable. And you can also do weighted averages. There's also a set of climatology tools. Yes. So let's get out of that. So there's documentation for NCO as well. So somehow the link to that fell out of my presentation. But anyways, I'll add a file with a couple more links for tomorrow, I think. So here's the documentation for NCO. Anyway, it's not hard to find if you Google the issue. So you can go into the different operators here and look at their particular definition, their particular versions and definitions. So we have, so I'm going to look at my files just quickly with NCDump. Look at the Area 5 file first. And let's only look at the header. So let's do that. And we can see that the variable name is total precipitation. Its units is in meters, and yes. And also we see that yeah. And then the CANI-SEM data has precipitation flux instead of total precipitation, and it's in different units. So it's the precipitation per second rather than the number of total meters during the day. So in order to actually compare these data sets, we need to manipulate a bit to get them to be the same. So first off, we just want to rename the variable. So it's called the same, even if it's also needs to be redone a little bit first. So to do that, we use this NC rename. Let's look at the documentation for that. So let's go into NC rename. And we see that that's going to be NC rename, and then either attribute, dimension, group, or variable, and the old name, comma, the new name, and then we have the in file and the out file. So let's see. That's not right. So in practice, when we want to rename the variable, what we do is this. And I have that file before because I tested this, so I'm going to overwrite the file. And now we can look at the resulting file. So we can use ncdump on that and see that the file name has changed. Okay, so that's now it's called PR rather than TP, which it was used to be called. Okay, yeah, so I'm running a bit short on time here. So there are a couple other commands that, a lot of other commands that we can do in order to make those two files actually comparable. We need to remap a bit so they're on the same grid. We need to do some different things, which I have done, which you can have the pleasure of trying to find out. And I can share some help later or tomorrow for that. So let's go to the presentation again. Yeah, so there we go. And to use Net Cdf, finally, we might want to use our Net Cdf files in Python. We can use Python to make Net Cdf files. We can read Net Cdf files. And we can also change Net Cdf files. In practice, it's a bit more fiddly than using Cdo or NCO because you have to really keep your dimensions straight and know which one is which can be a bit hard. And also sometimes you need to pay a lot of attention to make the metadata transfer correctly. But a really good package to use is Xarray. It's a library for Net Cdf files. I think maybe Tom showed you the Net Cdf library. That's also a good library, but Xarray is a bit newer, so I recommend maybe using Xarray. It's a bit more up to date and has a lot of the same things, but a bit more. And Tom showed you matplotlib for plotting, and also Cartopy, I believe, for plotting on maps. And there's a lot more with NumPy. So I have done a lot of other manipulations using this these two files in order to make them comparable. And I've made some files that I can use Python to look at. I have a script that's called something. ER total 2020. And I think that one is plotting the total precipitation in 2020 for both of the data sets. So I have manipulated the files a bit to get some files that can be compared in this way. And you can look at this. This script is also added to the shared folder. And what I then get is 2 plots. Showing the Cdsr precipitation, total precipitation for the year 2020 in the SSP 585 projection, and the error 5 reanalysis data. So that's kind of a modeling of what actually happened in 2020, or at least closer. And we see we have roughly the same grid. And some somewhat different values. So the precipitation is a bit stronger in error 5. And you can also think about, thinking back to Jana's talk, why this might be, as error 5 is a very high resolution reanalysis model built on observations, and Cdsr is quite coarse. Okay, so what you can now do is you can try and find out what types of commands I needed to perform to get the data to actually be comparable. And you can either use these data and try and download yourself, or you can also do a similar exercise, starting with monthly temperature data, which you can find in the shared folder. If you don't want to download, you can work with those and try and make the error 5 and the Cdsr 5 data comparable, and try and make some plots and have some fun.